All right, so in today's lesson, we're going to continue to talk about triangles. To review sort of some things that we've done so far this semester, we have mainly focused on right triangles. With that perfect right 90-degree angle, we can do things like Pythagorean theorem, we can do SOHCAHTOA with our trig function ratios. However, these two processes only apply to right triangles. Not every triangle is a right triangle, so this other branch, this other family of triangles are called oblique triangles. There's two types of oblique triangles. An acute triangle is one where all three angles are acute, meaning they're less than 90 degrees. An obtuse triangle is a triangle where one angle is an obtuse angle, meaning that it's greater than 90 degrees. To label an oblique triangle, we're going to use uppercase letters A, B, and C to represent our angles. Now directly across from angle A, we're going to call this side A, but we're going to use a little lowercase a. Directly across from angle B is side B, lowercase b, and directly across from angle C, we get side C. So to solve an oblique triangle means that we're trying to find all the angles and all the sides. So to solve an oblique triangle, we need to know the length of one side and one of the following. So the length of one side and two angle measures, the length of one side and one angle measure and another side length, or the length of one side and the other two side lengths. This is going to lead us to 4 cases when solving oblique triangles. The first case is where one side and two angles are given. We call this a side angle angle. And you'll see in the picture here, it doesn't matter if the side is in between the two angles, that's an angle side angle, or if it's the side and then the next two angles are given next to it, so side angle angle. Case 2 is if two sides and the angle opposite one of them is given. So this is an SSA. So these are the two sides, and this angle is given. Notice how it's opposite of one of the given sides. All right, case 3 is when two sides are given and the angle in between them is given. So we call this an SAS, the side angle side. And then finally, case 4, SSS, where all three sides are given, no angles. So to go back, case 1 and case 2, we are going to be solving those using the law of sines, which we'll be talking about today. Today, actually, our focus is just going to be on case 1. Our next lesson, we're going to be talking about case 2. And next week, we are going to be talking about case 3 and case 4. These two triangles, we'll actually solve them using a different method called the law of cosines. Sort of a preview of where we're headed. Okay, so this is what the law of sines actually states. It states that the sine of angle A over side A equals sine of angle B over side B, and that's equal to the sine of angle C over side C. Now you could also flip the ratio. You could write it like this. So really, however you prefer, you're going to end up with the same answer. Now before we take a look at our first situation, I want to actually show you a proof for the law of sines, just to give you a little bit of background of where this comes from. So suppose we have an oblique triangle here, so it's labeled similar to how we talked about on the first page, and then we're also going to be referencing this other side length, the height. Notice how the height is the distance from the tip of our triangle there at the top, and it's making a 90-degree angle down here. So let's, for just a moment, think about just this left-hand side. Notice how it is a right triangle. Because it's a right triangle, we can use SOHCAHTOA. So I'm going to write a relationship. I'm going to write an expression that describes the relationship between these three side lengths. Sine of angle A is equal to opposite over hypotenuse. So I'm going to say sine A equals H over B. And then I'm going to multiply both sides by B. So we get B times sine A equals H. All right, we're going to hold on to that and come back to it in a minute. Let's take a look at the right triangle now on the right-hand side. So writing a similar expression with angle B, I'm going to write sine of angle B, this time equals opposite over hypotenuse. So the opposite side is the height. The hypotenuse is side A. And then similar to what we did before, I'm going to multiply both sides by A. Okay, so now we have two statements that are both equal to h, so we could almost think of this as a system of equations. If h equals b sine A and h also equals a sine B, that means that b sine angle A is equal to a sine angle B. All right, if we divide both sides by the same thing, that's okay because it's an equation. So if we actually divide both sides by sine A sine B, let's watch what happens here. Let's cancel the sine A's on the left side, cancel the sine B on the right side, and we're left with B over sine B equals A over sine A. So that is the first part of the law of sines. Now we could draw a similar picture and kind of write out a similar proof to show the last part, C over sine C. It's very similar. So I wanted to show you that just so that you can see that these formulas, they do have some meaning in terms of where they come from. They don't just sort of come out of nowhere. So this is what we'll be using for the law of sines. Okay, so to solve the triangle, remember solving a triangle means that we're trying to find the missing sides and the missing angle, or angles if there's more than one. Okay, so this is a first case side, angle, angle. So this is the side that we're given, the angle next to it, and then the angle next to that. So we can use the law of sines to solve this situation. So anytime you're given two angles, your first step, it's an easy step to start, should be to find the third angle. So we know that the angles of a triangle must add up to 180 degrees. So we're going to use that fact. We're going to do 180 degrees minus 33 minus 110 to give us our third angle measure, which is 37. As soon as you figure something out, label it in your picture. Speaking of labeling, let's also go ahead and add in our letters A, B, and C. And typically when our triangles are this way, we just typically usually put angle A in the lower left, angle B in the lower right, and angle C at the top. And go ahead and label our side lengths. Okay, step 2. We are going to find one of the missing sides. And so we're trying to find side B and side C. It actually doesn't matter which one you do first. We know angle A and we know side A. So we're for sure going to use sine A over A because we know both of those pieces. Let's say that we're just solving for side B first. So we'll go ahead and just use this piece of the law of sines and then go ahead and fill in the information that we know. So sine 110 degrees over 7 equals sine 37 degrees over B. This is a proportion. A proportion is a special equation that looks like a fraction equal to a fraction. We can cross multiply and divide to solve this proportion. So first when we cross multiply, we get B times sine 110. On the other side, we get that equal to 7 times sine 37. Okay, to get B by itself, we'll go ahead and divide both sides by sine 110. Now, when you type this into your calculator, you're going to want to double check to make sure that your mode is in degrees. If you type this in all in one step, you will also want to add a set of parentheses around your numerator. Also, after you press the sign button, your calculator is automatically going to give you a parenthesis at the start of it, so you want to go ahead and close the parenthesis behind it. So adding in parentheses here, that's kind of what that should look like. So 7 sine 37 over 110, we get B is approximately 4.5. And what we're going to do consistently throughout this chapter, anytime we're solving for a side length, we're going to round to the nearest tenth, which means we're rounding to one decimal place. Okay, as soon as we find something out, let's go back up here and label it in our picture. Okay, finally, step 3, we're going to find the other side. So I'm still going to use the original information, sine A over A, but this time I'm going to set that equal to sine C over C to help us solve for the missing side length of C. So we fill in what we know. Angle C was 33 degrees. We'll do the same step of cross multiply. And then divide both sides by sine 110. All right, so being careful with all of your parentheses when that goes into your calculator, we end up getting that C is approximately 4.1. Okay, so we solved the triangle because we found the missing angle and we found the two missing sides. Okay, our next situation, this is also case 1, but this is the angle side angle situation. So let's go ahead and start by doing some labeling. Labeling our A, B's, and C's. First step is the same as what we did before. We're going to find the third angle by subtracting the two given angles from 180. All right, so we'll go ahead and label that third angle 68 degrees. Okay, next step, we're going to find one of the missing sides. It does not matter the order that we go in. This time, the full information that we're given is for C, so we know angle C and we know side C. So we're going to be using sine C over C as kind of our given ratio. Let's solve for side A next. So we'll go in and fill in the pieces that we know. Okay, go ahead and cross multiply. And divide both sides by sine 68. All right, putting this into your calculator, adding all of your parentheses in the right places, we get A is approximately 18.1. All right, last step, we're going to find the other side. So let's still use sine C over C as our given ratio. This time we'll set this equal to sine B over B. So angle B is 32 degrees. All right, we'll go ahead and cross multiply. Divide both sides by sine 68. Add all of our parentheses in before that goes into our calculator. We end up getting that B is approximately 9.7. So we have solved the triangle. We found the missing angle, and we found the measure of the two missing sides. Okay, so we're going to finish up by looking at a few application situations on which we can use the lot signs to solve. I do need to give you a little bit of background to help us understand what's going to be going on in the next problem. So if you have just a blank sheet of notebook paper, maybe grab that, or if you can find some open space on the note sheet that you're using, I want to show you a few things about what we call bearings. All right, so bearings are going to be combining a direction with an angle measure, and they look like this. This stands for north, 40 degrees east. So we're going to kind of think about a compass and actually draw what kind of looks like an XY axis, or if you think about a compass, north, south, east, west. And so you're always going to start at the origin, start at 0, 0. The first direction that it tells you, so north, so we're going to travel up because that's north. Then you're going to go 40 degrees east. East is to the right, and so we're going 40 degrees to the right, and you're going to draw a little line out like this. The angle that we're measuring is always from the y-axis. So that's why bearings, it's a little different. Like Typically what we've been doing this semester is the angle measure. It's always in standard position, and we've been doing the angle measure from this line. Well, now for bearings, we're doing it from the y-axis. So this is what north 40 degrees east would look like. Here's another example. The bearing north 65 degrees west. So starting again at 0, 0, you're going to go north, and then west is to the left. So you're going to go 65 degrees to the left, and that's giving you the angle measure right there. All right, what about one like this? South 70 degrees east. So starting at 0, 0, south is down, east is to the right. We're going 70 degrees east. So that's what that one would look like. And let's do one more. Let's do a southwest bearing, south 60 degrees west. Starting at 0, 0, go south first, then go 60 degrees to the west, and it will look something like that. Okay, so let's take a look at this problem. It says the Hillstern brothers, who are co-captains of the Time Bandit on Deadliest Catch, they've taken their boat on the Bering Strait to catch Alaskan king crab. They receive word about a nearby hotspot to fish from, which means a good place to go. The bearing from the Time Bandit, that's the name of the boat, to the hot spot is north 50 degrees east. So let's take a look at the picture here. So here's the Time Bandit, here's the hot spot, that's where they're trying to go. And if we think about the bearings, so we're going to go north and then 50 degrees east. And so that's giving us an idea of the direction, the angle. Another boat, the Wizard, is 20 miles away from the Time Bandit. So you look at that here. They've also learned of the hotspot. The bearing from the Wizard to the hotspot is north 36 degrees west. How far is each boat away from the hotspot? So we're trying to figure out this distance and that distance. So we can think about using law of sines to help us. Now the thing about bearings is that the way that our drawings are set up, we are given the angle on the outside of our triangle. So we actually need to first start by getting the angles on the inside. This right here is a 90-degree angle. And so if we subtract 50 degrees, this first inside angle is 40. Over here, if we subtract 36 from 90, we get this inside angle to be 54. Okay, thinking about getting that third angle, if we subtract both of these from 180, we get that third angle measure to be 86 degrees. All right, let's go ahead and put in our labels. So angle A, angle B, angle C, side A, side B, and side C. So we know that side C is 20. We're trying to figure out the measure of side A and side B. So based on what we've done so far with a law of sines, we should be able to do this. So sine C over C, that's the given ratio. Let's find side A first. All right, so we'll go ahead and cross multiply. Divide both sides by sine 86. All right, careful with your parentheses when you're typing this in. And we end up getting about 12.9 miles. So that's the distance that the Wizard is away from the hotspot. So let's go ahead and see how far away the Time Bandit is. So that's going to be solving for side B. All right, we'll go ahead and divide both sides by sine 86. Okay, and we end up getting that B is 16.2 miles away. So the Time Bandit is a little bit further away than the Wizard is. Obviously, there's a lot of other factors to think about. If the question was wanting to know, who's going to get there sooner, there's a lot of factors, speed, wind, conditions in the water, lots of things that we can think about to continue this scenario. But if we're just figuring out the distance, that's how we do it. Okay, for this last question, we're just going to talk about getting our picture set up. Once the picture's set up, solving it will be really similar to the last one that we did. So I actually am going to have you pause the video, read through this problem, and then restart the video when you're ready. Okay, so let's start to think about our drawing. So we'll go ahead and draw an oblique triangle, kind of similar setup to how we did in the last problem. So we have the castle. Let's put that here at the top. There's you, and then there's your mom. Okay, so those are the three objects, that people and the castle, that are creating this triangle shape. All right, so it says that, okay, that means you. Okay, first off, actually, so it says I am 14 yards away from the castle. So let's go ahead and label that 14. Then it says my bearing to the castle is north 26 degrees east. So for your bearing, these dotted lines are helpful. So you're going to go north and then 26 degrees east. So that's 26 degrees right there. Okay. Mom texts back, my bearing to the castle is north 8 degrees west. I love this problem because these are totally real life text messages that you would send, right? Okay, this is asking how many yards is your mom away from you? So that's the first question. How far is your mom away from the castle? That is the second question. Okay, so from the outside angles, we have enough information to find the little angles on the inside. When you know two angles, you can get the third angle. Then you can use law of sines. Since you know your angles, you know one side length, you should be able to get the other two missing side lengths.